Hi, this is Carlos Cousins, and the following is an ACT question that is asking us to match a given diagram with a given graph. In this case, we're matching the diagram of what we're calling a secondary star, which is a larger star. We can presume it to be brighter for this exercise, and a primary star, which is a smaller star, which we can presume to be slightly fainter given the relative sizes. And we're asked to match by looking at figure 1, which is this light curve here, whether or not this diagram corresponds to the highest apparent brightness, the primary minimum, the secondary minimum, or both the primary and secondary minimums. Well, we know the highest apparent brightness from this graph because of the labeling here of the y-axis will have to be these points on the light curve right here. So how do we get the highest apparent brightness in this diagram? Well, we can imagine if the secondary star here has a certain brightness and the primary star here has a certain brightness, we don't want either star to cover any of the brightness of each other. Well, this diagram makes it seem like the primary star is the one moving, and at one point the primary star will be over here, at another point it will be over here, and another point it will be behind the secondary star, and you will no longer be able to see it. We can assume that when the primary star is not blocking any of the light of the secondary star but is on the outside, more light will be emitted by both stars, since the primary star will emit some and the secondary star will emit some. So in order to get the highest apparent brightness, the primary star wouldn't be able to cover any of the secondary star. But that's not the case. Here it's covering some. It's right in the middle of the secondary, so this can't be the right answer. The primary minimum. Well, the primary minimum is defined here in observation 1. It says, when the brighter star passes behind the fainter one. So that would mean, never mind, our assumption was wrong. The primary star then, since this is the one going behind, would have to be the brighter star, and the secondary star the fainter. Light from the brighter one is blocked, right? Because you can no longer see it since it would be behind the secondary star. And primary minimum is said to have occurred. So that would be if the primary star then was behind the secondary star. That would mean then that this brighter star is going to be behind this fainter star. But that's not going on. This brighter star is actually in front of it. So it can't be the primary minimum. Now, the secondary minimum here says when the brighter star passes in front of the fainter one. Okay, so here we'll have the brighter one in front of the second one. If we assume then that since the one moving is the primary star, and it is the only one that's going to be either in front or behind, light from the fainter is blocked and secondary minimum has occurred. So it looks like secondary minimum is what's going on. And this would be the answer choice. So then why are we looking at the light curve at all? Well, we know that the primary minimum is defined as the greatest total decrease in total brightness. So on the light curve, that would correspond to this portion of the graph. And this secondary minimum piece then would be when there's a little bit less light, but you still have the light from the primary star and the secondary star shining at the same time. So that would be this part of the graph. What we see is this goes around in a cycle, and in fact, you see that this has it's labeled cycle here, and it's got arrows that imply that the primary star is moving around in a circle. So as you go about, it's going to be very bright when it's not in front of the star. All of a sudden it's going to go behind the star. The primary star is going to go behind the secondary star, so all of a sudden it's going to get significantly darker. Then it's going to come out from behind, and it will get significantly brighter again, just as bright as before, because both stars are visible. And then the primary star is going to cover some of the secondary star's light, so it will be just a little bit less bright, but you still have the brightness from the primary star there. And then it's going to go out to the outside again, so that it will be just as bright as before. And it repeats in a cycle over and over and over again. Both the primary and secondary minimums, you can't have both at the same time, so that couldn't be the right answer either. So this is why choice C is the correct answer. I hope that this video helped. Happy prepping.